Hi, Algebra. In lesson 2 here, we are going to be creating our own number magic tricks. So have your paper behind or in front of you, and here we go. All right, so in number 1 here, we are creating your own number trick. We're going to do it in words and pictures like we've been working on. I'll give you some hints here to get you started. You can start by saying, think of a number. And we can draw a picture for that. We'll use our bucket. And as you go on, you can do things like add, subtract, multiply, divide. And it says you don't have to use all the rows, but try to use at least 5 rows. When you're done, have some other students try it. And then you're going to record their answers here, and you'll see if your number trick actually works. Have fun, be creative, get to it. Okay, let's go on to numbers 2 and 3, but before that, there's one piece that we want to talk about, this idea of communicating clearly. Throughout the lessons here, you'll see these little things pop up called algebraic habits of mind. These are just things that you want to be thinking about that we're working on developing, but aren't necessarily maybe seen on your paper all the time. So this idea of communicating clearly, it helps in math because not only do you get more credit for your work, right, when you show your work, but it also helps you learn more. When you communicate clearly, other people understand you better and can offer better suggestions to improve your thinking and strategies. So it's those ideas of explaining how you solved something and someone else can say, oh yeah, that's really interesting, but I solved it this way. Does that work as well? And when you're doing that, you are both learning a lot more and working on your communication skills as well as your algebra skills. Okay, on to number 2. Maria thought of the number 2. After one step, she got 8. Name 2 ways she could have gotten to 8. One way she could have done it was to add 6. And I want you to come up with your own second way that she could have done it, and start again when you're ready. And number 3, Hiroshi thought of the number 5. After 2 steps, he had 11. Name 2 ways that could have happened. Well, one way could be that he maybe multiplied by 2, because that would get him 10. And then he could have added 1 to get to 11. Find another way that could have happened. Start again when you're ready. Okay, on to number 4 here. If a bucket and 3 equals 9, then what does that bucket equal? Maybe you're thinking already what that answer would be, but one way we could show this is if we remove 3 from each side of our equation. We know it's an equation because of the equal sign. If we remove 3 from each side, we're left with 1 bucket equaling 6. And so we know that the bucket needs to equal 6. Number 5, if 2 buckets and 5 equals 25, then what does a bucket equal? Here's another way that you could look at this problem. Here's 5. And so I know that these 2 buckets need to equal 20 because then I would have 25 on both sides. If each of those buckets equals 10, then I would have 20 plus 5 equaling 25. So there's different ways to kind of show your work and work through those problems. However you do it is fine. Just make sure that you are showing your thinking on your paper and communicating that clearly. Okay, on to the discussing together problem. What number can the bucket represent so that the statement a bucket plus 4 is equal to 2 buckets plus 1 will be true? Well, here's a case where I'm going to take away a bucket from each side, and then I'm going to take away 1 from each side. And I see what I'm left with. I have a bucket is going to be equal to 3. And when you're doing these, you can always take your answer and plug it back in to check it. So if the bucket was 3, I'm going to add that to those 4 green dots that were originally there. Is that equal to what's on the other side if each bucket there was 3? And I would see that, yep, it does make it equal, and so we're good to go. On the next page, let's start with the discussing together section at the top. How many different numbers can the bucket represent in this statement right here? Well, if I notice something about this, it's 1 bucket plus 6 equals 1 bucket plus 6. both sides are exactly the same. And think to yourself, what can go in those buckets to make it true? What if the bucket was 0? Well, I now have 6 equals 6. It's true. What if the bucket was 1? Well, then I would have 7 is equal to 7. It's true. And because both sides of this are exactly the same, this is always going to be true. So for any number you put in there, it's always going to be true. The second one, how many different numbers can the bucket represent in this statement? A bucket plus 6 is equal to a bucket plus 3. Well, think to yourself, if I put in some different numbers into these buckets, if say the bucket is 0, I'd have 6 equals 3. That's not true. That's not a true statement. If the bucket was 1, I would have 7 equals 4. Again, not a true statement. And so this one is never going to be true. No matter what you put in that bucket, this will not be equal. Okay, here in number 8, we see something similar to what we just talked about. On this mobile, we have 2 buckets on each side, and then we have a grand total of 3 on each side. And so this would end up being the same on both sides, and that is why it always balances. So make sure you get that written down. In number 9, this mobile only balances when the bucket represents a certain number. So what number makes it balance? Well, here I'm going to simplify it by taking away a bucket from each side. And so what I'm left with is 1 bucket is going to be the same as 5. And you can double check that by writing down 5s by each bucket, and you would see that each side of the mobile ends up being 10, which makes it balanced. In number 10, we see that this mobile never balances no matter what the bucket represents. And why is that? Well, hopefully you notice that it's because the left side has 1 more and the rest of it is all equal. And so the left side is always going to be 1 greater no matter what you put in those buckets. Okay, number 11, does this mobile balance sometimes, always, or never? And if sometimes, when? So let's simplify our mobile. I'm going to take 1 bucket away from each side, and I'm going to take 1 dot away from each side. And so what I'm left with is that the bucket has to equal 3. So when does it balance? When the bucket equals 3. Okay, looking at number 15, how many diamonds are in a heart? You're given a mobile here, and we don't know what the value of these is, but we can simplify our mobile. I'm going to take a diamond away from each side, and I see that a heart is going to be the same as 2 diamonds. Okay, complete 16 and 17 on your own. Let me know if you have any questions. Hi, Algebra. Good work on finishing this lesson. Make sure you did those problems that you were supposed to do on your own here. And when you're done, get any questions you have answered and then move on Canvas.